CAM additive manufacturing. After completing this lecture, you'll be able to understand additive manufacturing in Fusion, describe the setup process, describe additive material definitions, and identify key steps in the additive process. First, we need to start with what is CAM. CAM stands for Computer-Aided Manufacturing, and it's a tool used to help program CNC machines to perform complex operations. CAM can be used to program CNC mills and lathes, water jet machines, laser and plasma cutters, 3D printers, and more. CAM tools are available in the manufacturing workspace in Fusion 360. What is the additive CAM workflow? In a manufacturer workspace in Fusion 360, there are a few key elements to the workflow for additive manufacturing. These are the basic steps required. First is setting up a print settings library. This is a digital library used to define parameters for specific materials and body presets. Next is creating a setup. This includes critical properties such as which machine is being used, which material is being used, and which models are included. The toolpaths are generally automated, but this is the path that the print head will follow when generating layer lines to build a part in 3D. Support material is generally added manually, and this is allowing a support structure to be created in addition to the 3D print. Support materials are generally breakaway for traditional desktop FDM or FFF machines. This material is often added when a print exceeds a designated overhang angle. This is the angle to which a print can no longer self-support. Simulation is used to validate the layer lines and support locations before committing to a 3D print. And finally, the G-code, machine-readable code that is generated by converting the toolpaths to a set of instructions for a specific machine. Print Settings Library. The Print Settings Library is a digital representation of the material that will be used in additive manufacturing. Data about the material is stored and selected during setup creation. Data contained in the print settings include things like the extruder and bed temperatures, layer height, and the infill type and percentage. Material is organized by technology, layer height, and name and vendor. Materials should be customized and saved in the cloud or locally with known good print settings for each machine you use. Toolpath and support creation. Toolpaths are routines used to define tool motion based on geometry. Toolpaths are auto-generated for additive manufacturing based on print material settings. Support materials are manually added based on parameters or manual selections. Supports are generated first, followed by the toolpaths. Toolpath validation is critical before any program is used on a 3D printer. Toolpaths can be validated by using Simulate Additive Toolpath. Simulations will display each layer as it is built, sped up to aid in visualization of adhesion, infill, and support settings. Toolpath processing. Toolpath processing is the last step before setting up a 3D print. NC programs are containers of information about which machine to use, which settings for that machine, and which operations are going to be posted. Posting operations is a method of converting the created toolpath in CAM to code that the machine can understand. Post-processing will provide G-code that can be loaded on a machine for 3D printing. In conclusion, CAM is used to create a digital print settings library and toolpaths to control extruder motion to print parts. Toolpaths in CAM are converted to machine-readable code for a specified machine. Simulations are used to validate toolpaths and support settings prior to post-processing. Posted G-code is transferred to a 3D printer to begin manufacturing parts.